Good day, students. Welcome to Mathgotserved.com. In this clip, we're going to be going over another topic on our virtual Algebra 1 text. We're going to be looking at how to graph linear equations in slope-intercept form. All right, let's take a look at the formula that will be guiding our problem solving process. So we're looking at, let's write down the formula for the slope-intercept form. Slope-intercept form. So the name basically tells you what the formula has. The formula tells you the slope and y-intercept. So the slope-intercept form of the equation of a line is y equals mx plus b. M represents your slope. Okay? Your slope is rise or run. Rise or fall. Rise or fall. Divided by your run. Okay? You rise when you have a positive slope, and you fall when you have a negative slope. So keep that in mind. This will be referred to as directions in our examples. All right? And then we have B. What is B? B is a y-intercept. This is where the line cuts the y-axis. We will refer to this as the beginning. This is where you begin. All right, so you need 2 points to graph a line. You begin with the y-intercept, and the directions from the slope will tell you how to locate the other point. All right, let's take a look at the instructions for the examples that we're going to do. So what we're going to do is we're going to graph the equation of each line given in slope-intercept form. So the first one, let's say we have y equals negative x minus 2. Okay, so let's take a look at that. So the solution is as follows. Let's rewrite the equation. Y equals negative x over 2, minus 2. All right, we'll start by writing down the equation of the slope-intercept form. The slope-intercept form is y equals mx plus b. M is the coefficient of x, b is the number that's being added to that x term. Now you notice that there's no number in front of the x, okay? So you have the invisible coefficient there, which is 1. So if no coefficient is in front of a variable, the default coefficient is 1. So with this setup, we can see that our slope is negative 1, and our y-intercept is b is negative 2. Okay, let's go ahead and write those down. So we're going to let's write them down with your names. So we're going to begin our graphing with the y-intercept. The y-intercept is b, so think about b as the beginning. The b value here is negative 2. And then we need the directions to take us to the second point. So what are the directions? The directions, in order to figure this out, this is where the slope plays a role. The slope is the m value, which is negative 1. So how do you graph this? Well, in order to have the directions, we need a rise and a run, or a fall and a run. This is just a number. We need a denominator component. Anytime you have an integer, you have to express it as a fraction if it is the slope. Okay? So since you have an integer, the default denominator is just 1. Okay? So you have a 1 right there. So this tells me my directions. I am going to fall 1 unit because it's negative and run 1. So this is my fall and this is my run. You always run and you rise or fall. Okay? Alright, let's use this information to graph our line. So we just create our coordinate system. And then let's label our axis. This is the y-axis and this is the x-axis. Now when we're graphing, we need only 2 points. Okay? So we always begin with the y-intercept. The y-intercept is b, which is -2. So you graph b first. Think about b as the beginning. That's where you begin from. And then you graph your y-intercept and then use the slope to find the second point. So let's graph the y-intercept. The y-intercept is -2 right here. So that's 1 point, -2. Now we need another point to graph the line. How do we locate the other point? This is where the slope plays its role. It tells us to drop 1 unit, so we're going to drop 1 unit and run 1 unit. Okay? Dropping 1 unit or falling 1 unit and running 1 unit is the same thing as rising 1 unit and going back 1 unit. See that these points are all collinear. Okay? So starting here, you fall 1 and run 1. You can keep going, fall 1 and run 1 again. Or you can rise and then go back. All these points fall on the same line right here. So let's go ahead and draw the line using all these points that we have. So this line right here is the graph of the equation of the line with the equation y equals -x minus 2. Okay? So let's go ahead and put the arrows because these lines continue forever. The domain and range is -infinity to infinity or all real numbers. Okay, so let's go ahead and label the equation. This equation is y equals -x minus 2. All right, let's go ahead and try another example. Question 2. Let's say we have the equation y equals 3x plus 2. Alright, we're going to follow the same procedure. So we write the equation. We have y equals 3x plus 2. Now we need the slope or directions and the y-intercept b or the beginning. Let's go ahead and write down the formula that's going to guide us in determining those values. Y is equal to mx plus b. We can see what m and b are. M is clearly 3 and b is 2. Alright, so we know where to begin and we know the directions that will take us to the second point. So we're going to begin from the y-intercept when we're graphing. The y-intercept is the b value, which is 2. The directions will come from our slope. The slope is m. In this case, m is 3. But 3 tells us just the rise since it's positive. What's the run? Every time your slope is an integer, please express it as a fraction so you know what your run is. Okay? So in this case, we are going to rise 3 units from the beginning, 2 on the y-axis, and then we're going to run 1 unit. So there goes my rise over run. Now let's go ahead and use these 2 pieces of information to graph the line. Alright, so there goes the coordinate system. This is my y-axis. Alright, and this is my x. Alright, so where do we start graphing from? You begin from b. b is your y-intercept. Don't forget. So our y-intercept is 2. And then what are we going to do from there? From our y-intercept, let's graph it first. Our y-intercept is 2 on the y-axis. That's where you begin. So from there, you're going to find the second point. You're going to rise 3, 1, 2, 3, and go over 1. Bam. All right. Can you find another point that's collinear with these two using the slope? Rising 3 and going over 1, if I go again, I'm going to go out of my grid. So can I go down 3 and back up 1? Is exactly the same thing. So I can fall 3, 1, 2, 3, and go back 1. It's still collinear. Okay, we could do it again. Fall 1, 2, 3, and go back 1. All these points fall on the same line. If you start from this line, you rise 3, run 1. You end up here, rise 3, run 1, rise 3, run 1. The slope is always constant for linear functions. Okay, constant means it stays the same. All right, so there goes the line of the equation. Y equals 3x plus 2. All right, let's put the name of the line there. So this is y equals 3x plus 2. And then our y-intercept is 2, and our slope is 3. All right, let's take a look at another example. What if we have a scenario where we have a fractional slope? Question 3, what if we have y equals 1/2 x minus 2? All right, let's take a look at this one. Let's rewrite the problem. Y equals 1/2 x minus 2. So to graph this, we need to know where to begin and what our directions are to the second point that helps us define the line. We're going to write down the formula that's going to guide us in determination of our beginning value, the y-intercept, and our directions to slope. Y equals mx plus b. Now, the m value is the coefficient of x. In this case is 1/2. And the b value is the other number. In this case, it is -2. So we know where to begin, and we know the direction. So let's go ahead and specify. Where are we going to begin from? You begin from the y-intercept. Your y-intercept is b, and in this problem, b is -2. So we're going to start from -2 on the y-axis. Okay? How do we find the second point? Directions coming up. The directions is the slope. The slope is your m value, which is 1/2 here. Now, what is the rise and what is the run? If your slope is a fraction, it automatically tells you your rise and your run. In this particular example, the numerator is your rise, since it's positive, and the denominator is your run. All right, so we're going to rise, starting from the beginning, -2 on the y-axis, we're going to rise 1 and run 2. Okay? All right, let's go ahead and graph the line. All right, so let's start by graphing our y-intercept. So our y-intercept for this example is -2. So we go down 1, 2. So go down 1, 2, -2. That's going to be our y-intercept. And then from there, we're going to look for the second point for the graph. Okay, so that's 1, -1. Okay, this is your y-axis. So let's start by graphing our y-intercept. Our y-intercept is -2. And then from there, we're going to rise 1, following the directions of the slope, and run 2. 1, 2. You rise 1 and run 2 to get to the second point. We can do it again. Rise 1 and run 1, 2. Takes you to the point. Or we can go back for 1 and back up 1, 2. Takes us to another collinear point. All these points are points on the linear function y equals 1/2 x minus 2. Okay, so let's go ahead and graph it. The line looks something like this. Bam. There goes the graph of your linear function. So let's label it. This line has the equation y equals 1/2 x minus 2. All right, let's try one more example. What if we have a fractional slope that is negative? How are we going to graph that? Let's say we have y equals -4/3 x plus 3. All right, so to do this, we're going to start by writing down, let's rewrite the problem, y equals -4/3 x plus 3. And then the formula that will guide our determination of m and b is the slope-intercept form, y equals mx plus b. So from this setup, we can clearly see that our m is -4/3 and our b value is +3. Okay, so we know where to begin and we know what our directions are to find the second point. So where do we begin? We begin at the y-intercept. The y-intercept is b for beginning, which is 3 in this case. Our directions to the second point to help us define the line, we're going to use the slope. The slope is the m value, the coefficient of x, and it is -4/3 in this problem. In this problem, we have -4/3 as the slope. So we're going to, instead of rise, we're going to fall 3 units. Sorry, 4 units. We're going to fall 4 units, and then we're going to run 3 units. So in this case, we have a fall over run because of the negativity of the slope. All right, so with that in mind, let's go ahead and graph the function. All right, we have our coordinate system. Let's label it. This is my our y-axis. This is the x-axis. Okay, so where do we start from? Where do we begin? You begin with b, the y-intercept, which is 3 in this case. 1, 2, 3. You begin with the y-intercept, and then we're going to fall 4 and run 3. Let's do that. So we begin with the y-intercept, and then we're going to fall 4, 1, 1, 2, 3, 4, and then we're going to run 3. Okay, 1, 2, 3. So these are the 2 points that define our line. We can do it again for 1, 2, 3, 4, and run 1, 2, 3. See, these 3 lines are collinear because the slope is constant. We applied exactly the same fall over run number to the point, so that's why they all line up perfectly. Okay, so this is what the line for the function y equals -4/3 x plus 3 looks like. Okay, so let's go ahead and label the function. This is y equals -4/3 x plus 3. Okay. Now, how well did you master the contents of this presentation? In order to demonstrate mastery, we would like you to try out the following problems. So, instructions are still the same. You're to graph the equation of each line given in slope-intercept form. Alright, so question 1. What if you have the line y equals 1/2 x minus 4? Number 2, y equals negative 1 over 5x minus 3. Number 4, y equals negative 2x minus 2. And then number 4, sorry, this is not number 4, this is number 3. Number 3, and then number 4, what if you have y equals 3x plus 2? Okay, so what we'd like you to do, go ahead and pause this video and graph these 4 lines. And then when you're done, click on play and you will see what the answers are. Alrighty, so hopefully you had a chance to go work on the problems. These are the answers to questions 1 to 4. So for number 1, m is 1/2 and b is negative 4. So this is negative 4, and you can see the slope triangles happening there. For number 2, m is negative 1 over 5, and b is negative 3. This is negative 3 right here. For number 3, the slope is negative 2 over 1, and b is negative 2. You can see negative 2 right here. And then for number 4, m is 3 over 1, and b is 2, and that's 2 right there. Okay? So this is how you graph linear functions presented in slope-intercept form. Thank you so much for taking the time to watch this presentation. Really appreciate it. If you found the contents of this tutorial helpful in your studies of graphing linear functions, do give us a thumbs up, your positive feedback, and we really appreciate it. If you have any questions, comments, or requests, just post it in the comment section below. Don't forget to subscribe to our channel for updates to other presentations such as this. More clips, worksheets, games, and support resources can be found at mathgotserved.com. Do check it out. Thanks again for watching and have a wonderful day. Goodbye.